In this video, we'll be going over Peaking Iterator. So design an iterator that supports the peak operation on a list in addition to the hasNext and next operations. So we implement the Peaking Iterator class, which is given a iterator of an array here. And then in the next method, we want to return the next element in the array and then move the pointer to the next elements. Or in our hasNext, so we return true, there are still elements in the array we can output. And then the peak, so we want to return the next element in the array without moving the pointer. Let's go over the first example. So we're given the peaking iterator and we're given input array 1, 2, 3. When we invoke the next method, we're currently at here at the 0th index. So we return 1 and then move our index to 2. When we invoke the peak, we want to return the current element without moving the current pointer. So we return 2. And then we have our next method. So we return 2 and then move the pointer to 3 here. And then when we invoke the next method, we return 3 and then move our pointer to out of bound. This is why when we invoke the hasNext, there are no more elements left, so we return false. So let's go over the dot process. So let's first go over what is an iterator. So we can represent our iterator as an index I in an array. When we invoke the next method, we have to return the elements at index I, then increment I. Then when we invoke the hasNext method, we will check if I is out of bound or not. Because if it is out of bound, there are no more elements left. Then when we invoke the peak method, we will return the elements at index I without moving I forward, so without incrementing I. But now let's go over the peaking iterator. So the iterator that we are given in our constructor only has two methods. It only has next and hasNext. And we can see that next will always move our pointer to the next index, as we see here. So when we invoke the peak method, when we want to implement our own peak method, we have no choice but have to move our pointer I to the next index. So when we perform a peak operation, we have to return the elements at index I and have to move our pointer to I plus 1. This is because our iterator that we're given can only invoke the next method. So we have to move our pointer. But when we want to invoke the next method again, after our peak, we have to return the elements at index I from before, right? Because we invoke a peak, and then when we invoke a next, we want to return the same element. Because our peak operation should not move our pointer forward, but we have no choice of moving it forward based on the iterator that we're given. This means we should save the elements at index I every time we perform a peak operation. Because every time we perform peak, we can save the elements. And then next time we want to invoke the next method, we can just return the saved element instead. So let's go over the code. So the fields that we need is the iterator. This will be the input iterator. This will just be our private field inside our current class. And then whoever saved is our saved value. Initially, it will be null to represent we don't have a saved value currently. And then in the constructor, we're going to set our current element. We're going to initialize the iterator in our class. And then we have a peak method. So with peak method, we will first check if there's a saved value or not. So if saved is not null, this means we could just return the saved method instead. So we can just return saved. Else we want to set saved to iterator.next. So we want to save the current element at index I and then move our pointer forward to I plus 1. Then we can return saved. Now in our next method, we will return the elements. We'll first check if we have saved element or not. So if saved is not null, we want to set save to null again because we have move a pointer forward now. Because after we have invoked the next method, we do not need saved anymore. So I'm going to create a variable, copy, and set it to saved. And then we're going to set saved to null again. Then we can just return the copy. Else we can just return, if saved is not null, this means we did not perform our peak operation. So we can just return iterator.next. We can just return the next elements. And then hasNext, we will check if saved is not null, or iterator.hasNext, we can just return true. Else we'll return false. So let's go over the time and space complexity. For our space complexity, we get O of 1 because our iterator is from the constructor. And then our peak, the time complexity is O of 1. The next time complexity is O of 1, and our hasNext is O of 1. Now let's go over the code. So we'll first have our private class or private field iterator that we will be given from the constructor, and then we have our saved value. Initially null. Now in our peak, we'll first check if we are saved or not. If saved is not equal to null, we can just return saved. Else we want to save the current elements at the current index. So iterator.next. And then we want to return it. And then we want to return the saved value. And then our hasNext, we'll first check if saved or not. If saved is not equal to null, we want to return this value. But before that, we want to remove it now because we have already used this element. We do not need it again. So integer copy is equal to saved. Saved is equal to null, and then we can return the copy. If save is not equal to null, we can just return the current elements and increment our pointer. So return iterator.next. Our hasNext will return true if saved is not equal to null, or iterator still have next elements. Let me know if any questions in the comment section below.